Hi friends, this is Ramnath Mani and I am covering a series of videos on the evolution of industrial automation in US. In the first of this series, I had already published two videos on my interview with Lee Pryor, a veteran of industrial automation for over 50 years in US. In the third part of my interview with Lee Pryor, he talks about the evolution of PLC and the way forward and how it has been applied and how Ethernet came and how IT entered into manufacturing. He has given a lot of insight into how industrial automation progressed in the US, and it's a very interesting interview. I would like you to see it and give your comments. It's my intention to contact other veterans of the industrial automation industry in the US and present more insightful details of the evolution of industrial automation in USA. Thank you. I thought the first real change came when actually, the control cables in very large numbers were more or less, replaced with wireless. Otherwise, I remember
Yes.
the olden days when we had to go and commission PLCs and drives in plants, and we had to lay down tremendous amount of cables because each of these departments were in different places. They were
Yep.
separated by meters, kilometers, etc. And then, you have to run through a lot of control cables here and there. And then the other major problem was the interference between control cable and the power cable,
Oh God.
which caused
Yes.
tremendous amount of
Yes.
problems. So
Oh,
the first, I think, real change came when everything became wireless, and wireless started to be using, which eliminated or reduced the use of control cables to a large extent. And Ethernet was one of the major, I would say, connectivities that helped that. You know.
yes. Yes.
So then I think it evolved slowly. It went up I would say, the automation pyramid, and then we had the SCADA coming in. You know, and,
Exactly.
and
Exactly.
I think when the SCADA came in, there were quite a number of operators. Alan Bradley, of course, was one of them, and so was Siemens, so was ABB, and a number of these
Yep.
came into the picture. How were you exposed to that part of the business?
Well, that's an interesting question. Of course, that type of evolution came near the latter part of my career, of course, and I do remember you talk about power and control cabling together. In 2009, the summer of 2009, I took an assignment to go to Singapore for 10 weeks to help on a pharmaceutical plant that was being built. And it was using Schneider products. And they were having tremendous, first of all, they were product uh, management issues, not product, project management, which I was asked to help with. But one of the problems I encountered was this factory had been designed with a floating ground. And then they had put a lot of the Ethernet cables in the same trough with power cables. And of course, at that time, I can't remember what it was, but we also had our own protocol of communication cables, and that was in there. Okay. And we were having a heck of a problem with signal, loss of information. And it took us a lot of work. I finally brought in an expert from one of our German offices, German laboratories. The guy was a network expert, and he figured it out. And we told him, listen, you got to separate Ethernet and control cabling from the power. You can't run them together, especially where there's no floating ground. And so that's when it really started. But that's also part of how IT started to get more interested. So, eventually you get SCADA. Well, the next thing that happens is SAP. like you and I worked on together, right?
Yes, absolutely.
And
Absolutely.
now we're trying to send information all the way up to IT for manufacturing planning purposes, right? And the next step is, well, let's send in information from manufacturing planning and SAP back down to the factory floor. Well, now you have to merge IT with OT. You absolutely have to. They have to work together. And I'm sure the people managing it today and coming up, recognize this and are working, I hope, working together, and that there's no longer this tension between IT and manufacturing engineering. But I mean, that's really, I think, SAP and all the manufacturing planning, different types of Oracle or whatever it is, planning software is, I think, has been one of the drivers of forcing the two closer together.
Yeah, very right. You are absolutely right. That's how it evolved as it went in time. And in between, of course, the digital technology came in. And
Right.
when everything started getting digital, it was around, I think, around the 90s.
Yes.
Everything became digital. And then post 2000, of course, you saw computerization in a very major way into the factories and I
Right.
getting into it. Of course,
Yep.
the SAP. And then, of course, the MES, which came in between,
Right.
to communicate
Exactly.
between the factory automation and the ERP per se.
Right.
That's how I think the whole thing developed. And how have you been involved in this evolution?
Well, beyond the project in Singapore, not very much, because that was one of my last projects of this type that I worked on. But I have stayed involved and very interested in the industry. So, as you know, I worked as a consultant for a few years with our friends here in Raleigh, and tried to bring them together with the factory automation people. We tried to get them together with Rockwell and so forth. And I think they actually did, I think, some pioneering work, but maybe we weren't at that time talking to the right people. But anyway, I mean, I thought it was very interesting, and I tried to keep my hand in that way. Uh, I still, I'm a 50-year member of the IEEE, and I guess I'm now considered a senior member of the IEEE. But I read the magazine every month and try to keep up with the technology. Uh, a lot of it, of course, has gone way beyond me, but I still find it fascinating to open the magazine and read the articles, and then see something and think about, oh yeah, how could that be applied? And I'm sure if I was still in the business today, it would be just as fascinating as it was back in the 1970s. But I think to get to that point, I mean, I enjoyed seeing how things were made and how factories operated. Okay, I mean, I just loved walking into a factory and have somebody show me their production line and show me how it was made. I mean, I had a customer in the 1970s that I helped with early automation, SC Johnson Company. And one of the things they attempted, they make a lot of products, home care, personal care, like shaving cream, men's aftershave. And so they were attempting to come up with a new men's aftershave where they wanted to insert the label inside the bottle into the liquid, kind of like the idea of a ship in a bottle. And they never figured out how to do it at that time. The technology just wasn't available to allow it. But I loved working with them on projects like that, and to walk down a line and see a new line for this or that, and sometimes my friend in manufacturing engineering, we'd be going down a line of let's say shave cream, and at the end of the line, he'd just reach over, grab a can, and say, "Here, take this home, use it." Okay.
It's
But
really,
it's to me, it was always great fun to watch things being made and to learn how they did it. I mean, I worked a good bit in the stamping industry, stamping machines for automotives. I ran a group for about 3 years that made controls for the presses. I worked with Schuler in Germany and in Brazil and with some American press manufacturers, and to see how a car body was shaped, to me, was was a fascinating thing. Or to see how a we did a lot of engine line work, a lot of automation of engine lines. It was fascinating, you know,
Absolutely
to
right.
understand the steps. Now,
How how
everybody's not. Go
how
ahead.
you were involved with IEEE and probably ISA. How did these organizations actually help the automation industry and grow from the
I,
technology
I,
point of view?
that's a good question. I don't think IEEE, of course, had a subdivision, for factory automation. But IEEE is so big with so many interests, between chip manufacturing and this and that, microwaves, everything, that I don't think that IEEE, other than sponsoring meetings like the one I presented a paper at, I don't think IEEE had a tremendous influence. I think ISA probably had a bigger. ISA used to have a yearly exhibition. I remember in my early days taking our PLCs down to Houston in there was a football stadium we took over and did our exhibitions there, and that went on for many years. So I think ISA had a much bigger role to play in automation, although they were more interested in SCADA than they were in factory automation and machine control. I think that there are other organizations today, Mesa, uh, manufacturing automation. I forget the rest of the, but I think they're playing a big role in helping educate people, certify people, and so forth. So that's probably the big, as far as institutions, they and ISA are probably the two most influential in the USA. Okay, now on the other hand, there's also the IEC, and that's really like watching grass grow. I did for some few years sit on a body that was part of the IEC for a protocol that we were trying to develop for connecting SCADA and PLCs. I was on the board of directors along with people from
Mhm.
Siemens and Rockwell and Mitsubishi and others. And, I had an engineer from our company, a very smart guy who was an expert in communications protocols, work going with me. And they worked very hard on protocols and trying to get everybody to come to agreement. And of course, that's like the UN. When you bring together that many companies at the global level, it's like the United Nations to
Yes,
try to get everybody to agree
yes, I know.
on,
It's
on, on what the technology should be. And of course, the driver from it was interoperability. And of course, that's another, we haven't touched on that yet, but today, with so many products from so many different manufacturers, interoperability is so important. And those early days of working on industrial protocols, I mean, that was really the goal, to make it easier for a Siemens to communicate with a Telemecanique, SCADA, or whatever. Okay, uh, and eventually it has all kind of merged together. And again, you have to look at Ethernet and wireless communication. Today, I won't say it's a snap, but it's much easier to take multiple products from multiple manufacturers and have them communicate on a production line.
absolutely.
It was.
I think
I mean, you never saw people mix and match before. I mean, that's why, from a sales standpoint, you wanted to lock in your customer on your product. And frankly, we did that with Chrysler Engine for many years. They wouldn't look at anybody else. Ford stamping presses, wouldn't look at anybody else, you know. But eventually, with Ethernet, things come together and you can communicate between different brands.
Yes, absolutely. I mean, that was another, I would say, a big change that came into the automation industry, where you could have a common, communicating platform with any of the manufacturers.
Right.
Now, the other thing, of course, what interests me is that you have been so deeply involved in the industrial automation area for many, many years, and you have seen a lot of changes coming since probably you have been, not that active. But what do you perceive, let's say, going forward? Do you think any of the traditional automation products will they undergo any changes? Revolutionary changes, or they will continue to remain where they are, probably improve every day, but
Well,
and
first
they
of
will work along with IT in a smooth and
well, I think
fashion.
first of all, and I could see this even at the end of my active career, that the big change that was coming, first of all, was distributed logic. So that rather having one huge PLC device controlling the line, you could now start to take your distributed logic, again, because of Ethernet and wireless communications. You could have a small control panel for one part of the machine with its own logic controller with the logic and IO just for that part. And it would communicate across a network with everybody. So I think that the first real step to this was distributed control. And I could see that coming very quickly. And I really thought it was a good trend. And I'm sure I haven't been in a factory in a few years now, but I'm sure that if I was to talk to one of my old machine tool customers, I'm sure I'd learn what they were doing. And let's take something like FedEx or UPS. Certainly, and I'm familiar with some of their conveyor lines because we worked on some of those projects. Okay, that's a beautiful example of needing distributed logic because you've got all these containers, you've got all these conveyors, containers, shuttles, and they're all going every which way. It's just mind-boggling when you look at the design for a conveyor system, for a sorting system, like a hub for FedEx. Okay, and of course logic today can be distributed all over the floor of that plant instead of a lot of wires running from one central controller, maybe controlling 5% of it, and then you got to repeat that. Instead, you just distribute the logic, build it right in with even the sensing devices. And I think that was the other trend I was starting to see was to talk about putting logic right into a sensing device. To you know
You are absolutely right. I mean, of course, today, I mean, the terminologies are different. They call it the edge. You know, what we would probably
right,
think as
exactly. I've heard that. Yes,
distributed system.
right.
Finally, I would, probably like to ask you that in your long experience of automation, probably over than 50 years of automation, how do you see that, the automation industry, it originally evolved as a mainly OT platform. Then, IT was involved in it, and now it's an IT OT convergence. How do you see the basic automation products evolving? Do you think there'll be any change, or they will continue to be what they are?
Well, I've already touched on the idea that the logic would be more distributed.
Mm.
Even in some cases, right down to the sensing level. Uh, I'm sure some smart people somewhere will come up with a way, and probably it will be thanks to artificial intelligence evolution. To come up with a better way to control production lines. And the goal is always to make them more productive, more efficient. But the other goal, and this is, I felt this has never been talked enough about with automation, and I alluded to it before talking about painting and welding. there are great benefits in factory automation for humanity. I mean, just to take a car, if you take a car made in the 70s versus a car made in 2024, the 2024 car is going to last much longer. And that's because of factory automation. I mean, everything is done so much more precisely, but it's repeatable, it's predictable, it's time after time. But, you just, it'll just continue to evolve. But what it'll look like in 20 years, it's very hard to say, very hard. But I hope I can, maybe 20 years would be pushing it, but I might still see it. But what I would appreciate in the coming years, if you hear about an artificial intelligence application in factory automation before I do, I'd certainly like to hear about it and know about it.
Oh, that will be excellent. Anyway, Lee, I mean, it was fantastic talking to you and, getting experiences that you have faced in your long career. As I said, my intention is to actually talk to people who have long experience, who have been in the industrial automation arena for a very long time, and share their experiences and, share it with people who are the present generation to know how it all evolved. And I thank you very much for being part of this conversation. And
my pleasure.